Hello everyone, welcome to Neso Academy. We are learning theory of computation, and in the previous lecture, we have understood what is an epsilon NFA and how to calculate epsilon closures of all the states of an epsilon NFA. And now in this lecture, that is epsilon NFA to NFA conversion introduction, we are going to understand how to convert an epsilon NFA to its equivalent NFA. So in this lecture, we will cover the topic epsilon NFA to NFA conversion. But why there is a need for converting an epsilon NFA into NFA? I have told you that our ultimate goal is to get a DFA because DFA is used for practical implementations. Now, if we are given with an epsilon NFA, then first we need to convert that epsilon NFA into NFA. And then we can easily convert the NFA into its equivalent DFA. In the previous lectures, I have already explained you how to convert an NFA into its equivalent DFA. So in today's lecture, we will understand how to convert an epsilon NFA into its equivalent NFA by removing the epsilon transitions. So let's get started. So here you can see we are given with an epsilon NFA. So given is an epsilon NFA, that is a non-deterministic finite automaton with epsilon transitions. This is the transition diagram of epsilon NFA. Now, our objective is to convert the given epsilon NFA into its equivalent NFA. That is, we need to convert this epsilon NFA into its equivalent NFA. And this we can do by eliminating these epsilon transitions. So we need to follow some sequence of steps to perform this conversion. Let's see the procedure. Step number 1 is to find the epsilon closures of every state of the given epsilon NFA. So in the very first step, you need to calculate the epsilon closures of all the states of this epsilon NFA. And this we have already understood in our previous lecture. In the step number 2, construct the new transitions using epsilon closures. So these are the transitions of this epsilon NFA, but we need to convert this epsilon NFA into its equivalent NFA. That is why we need to create the new transitions for our resulting NFA. And this is the most important and the prominent step of this conversion. Don't worry, we will understand this step in detail. The step number 3 is to update the final states. So this D is the final state of this epsilon NFA, but we need the final state of our resulting NFA. So in the step number 3, we will find the final states of our resulting NFA. In the step number 4, construct NFA transition table and transition diagram. In the step number 2, we have already calculated the new transitions of our NFA. So from these new transitions, it is very simple to create the NFA transition table and NFA transition diagram. So these are the 4 steps that we will perform in order to convert an epsilon NFA into its equivalent NFA. Let's start with the step number 1. Step number 1. Find epsilon closures of every state of the given epsilon NFA. So, in the step number 1, we need to find the epsilon closures of all the states of the given epsilon NFA. In the previous lecture, I have explained you how to calculate the epsilon closure. And fortunately, we have taken the same example in our previous lecture also. I have explained you that epsilon closure of a state Q is the set of all states reachable from the state Q using only epsilon transitions, including the state Q itself. That means, if I want to calculate the epsilon closure of the state A, I need to find all the states that I can reach from the state A using only epsilon transitions. In this diagram, you can see from the state A, I can reach the state B using only epsilon transition. From the state A, I can also reach the state D using two epsilon transitions. That is why both B and D will be the part of epsilon closure of A. And according to the definition, epsilon closure of a state Q will also contain the state Q itself. That is why the epsilon closure of the state A contains three states, A itself, B, as well as D. So this is how we calculate the epsilon closure of a state. And similarly, we can find the epsilon closure of all the states of this epsilon NFA. In this way, we are done with the step number 1. Now we will proceed to the step number 2. Step number 2. Construct the new transitions using epsilon closures. So in this step, you are required to construct the new transitions using the epsilon closures of the states that we have just calculated. So these are the epsilon closures of the state A, B, C, and D according to this transition diagram of epsilon NFA. If you still have any doubt regarding how to calculate the epsilon closures of the states of epsilon NFA, then kindly refer to the previous lecture. In the previous lecture, I have properly explained how to calculate the epsilon closure for all the states of epsilon NFA. So, proceeding with the step number 2, we need to construct the new transitions using epsilon closures. These are the transitions of this particular epsilon NFA. But we don't need these transitions. We need the new transitions for our resulting NFA. So how to calculate the new transitions? We have a standard formula to calculate the new transitions of our resulting NFA. And this is the formula for calculating the new transitions of our NFA. The formula is delta dash Q comma A is equal to epsilon closure of delta epsilon closure of Q comma A. Now in this formula, this delta represents the old transitions of epsilon NFA and this delta dash represents the new transition of our resulting NFA. So we have to calculate the delta dash for all the states of epsilon NFA so that we can get the new transitions of our NFA. So delta dash Q comma A means the new transition from the state Q on input symbol A. Now let's understand the right-hand side of this formula. So if a machine wants to read the input symbol A from the state Q, then machine can first read any number of epsilon transitions, then machine will read the input symbol A, again machine can read any number of epsilon transitions. So before and after reading the input symbol A, machine can go through all possible epsilon transitions. And that's what represented by this formula. First, before reading A, machine can move through all possible epsilon transitions. Then, machine will read the input symbol A. And after reading A, machine can again move through all possible epsilon transitions. That means epsilon transitions, input symbol A, again epsilon transitions. That is the scenario represented by this formula. Now, this formula can be a little bit complex for you to understand. But when we will calculate the new transitions using this formula, you will find it easy to apply this formula. Let's calculate the new transitions for all the states. That means we need to calculate the new transition for the state A on input symbol 0 and 1. We need to calculate the new transitions for the state B for input symbol 0 and 1, and similarly for the state C as well as for the state D. Let's start with the state A. Delta dash A comma 0 is equal to epsilon closure of delta epsilon closure of A comma 0. Now you can see Q is replaced by the state A and the symbol A is replaced by the symbol 0 because now we are calculating the new transition for the state A on input symbol 0. According to this formula, first we have to calculate the epsilon closure of A. And here we can see epsilon closure of A is equals to A, B, D. So we will replace this epsilon closure of A by this value. And we can see here we have written A, B, D. Now we need to calculate delta of A, B, D on input symbol 0. So we can expand this as delta A, 0, union delta B, 0, union delta D, 0. And now we can simply calculate the transitions according to this diagram. A on 0. A on 0 gives A, B on 0. So B on 0 gives C, D on 0. D on 0 again gives D. So this can be written as A union C union D. Now, on taking the union of these three sets, we will get A, C, D. And finally, we need to calculate the epsilon closure of A, C, D. This can be written as epsilon closure of A union epsilon closure of C union epsilon closure of D. And now here you can see epsilon closure of A is A, B, D. Epsilon closure of C is only C, and epsilon closure of D is only D. So you will get the result as delta dash A, 0 is equal to A, B, C, D. And this is the new transition for the state A on getting input symbol 0. And this is the first transition of our NFA. Now we will calculate the second transition, that is the transition for the state A on input symbol 1. Now we have replaced this Q by A and A by the input symbol 1. Again, we need to replace this epsilon closure of A by this value. So we have replaced it. Now we need to calculate delta A, B, D on the input symbol 1. So we can write it as delta A, 1 union delta B, 1 union delta D, 1. And now we can calculate these transitions according to this diagram. A on input symbol 1. So here you can see the state A does not have any transition for input symbol 1. So this will be replaced by phi. B on getting input symbol 1. Here you can see B also does not have any transition for input symbol 1. That is why this will also be replaced by phi. D on 1. So D on 1 gives the state D. So this will be replaced by D. And we will get phi union D. That is why we will get D. So the epsilon closure of D, here you can see epsilon closure of D is D. So delta dash A, 1 is equal to D. This is how we have calculated the new transition for the state A on input symbol 1. Now we will calculate the new transition for the state B on input symbol 0. So we have replaced Q by B and A by 0. Again we will calculate the epsilon closure of B. Here you can see epsilon closure of B is B, D. So we will write B, D. Now we can expand this as delta B, 0 union delta D, 0. Let's calculate delta B, 0. So B on 0 gives C and D on 0 gives D. So this can be replaced as C union D. Now on taking the union of these two, we will get C, D, and epsilon closure of C, D can be written as epsilon closure of C union epsilon closure of D. And epsilon closure of C is C and epsilon closure of D is D. So finally on taking the union, we will get delta dash B, 0 is equal to C, D. Now we will calculate delta dash B, 1. Epsilon closure of B can be written as B, D. Again, delta of B, 1 union delta of D, 1. Delta of B, 1, we don't have any transition for that. And delta of D, 1, yes, delta of D, 1 will be equal to D itself. So we will get phi union D. And finally we will get D epsilon closure of D is equal to D. That is why delta dash B comma 1 is equal to D. Now let's calculate delta dash of C comma 0, because we have already calculated delta dash A comma 0, A comma 1, delta dash B comma 0, B comma 1. Now let's calculate delta dash of C comma 0. So epsilon closure of C will be replaced by C. Now delta of C comma 0. In this diagram you can see that the state C does not have any transition for the input symbol 0. So this will be replaced by phi, and epsilon closure of phi, we will get delta dash C comma 0 as phi. Now let's calculate delta dash C comma 1. Again we will replace this epsilon closure of C by C. Now delta of C comma 1. Here you can see C, on getting input symbol 1, we will get the state as B. So this will be replaced by B. And now we will calculate the epsilon closure of B. Here you can see epsilon closure of B is B comma D. So here we will write B comma D. So this is the resulting new transition for the state C on getting input symbol 1. Now let's calculate delta dash D comma 0. Here epsilon closure of D will be replaced by D and delta D comma 0. So delta D comma 0 is D itself. So this will be replaced by D, and epsilon closure of D is D itself. So delta dash D comma 0 is equal to D. Now we will calculate our last transition, that is delta dash D comma 1. Epsilon closure of D will be replaced by D. Delta D comma 1 will also be equal to D, and epsilon closure of D will be equal to D. And finally we will get delta dash D comma 1 is equal to D. In this way, we have got all the new transitions for all the states on all the input symbols. We have calculated the new transitions for the state A on input symbol 0 and 1, for the state B on input symbol 0 and 1, for the state C on input symbol 0 and 1, and similarly for the state D. These are the new transitions for our resulting NFA. And in this way, we have completed our step number 2. Now let's proceed to the step number 3. Step number 3 is update the final states. That means in this step, we are required to update, or you can say find, the final states of our resulting NFA. Let's see how to find. If the epsilon closure of a state contains at least one final state of the epsilon NFA, then that state becomes a final state in the NFA. What does that mean? Whenever we calculate the epsilon closure of any state of epsilon NFA, we will get a set of states. And if that set contains at least one final state of the epsilon NFA, then the state whose epsilon closure we are calculating becomes the final state of our resulting NFA. So, for this diagram, we have calculated the epsilon closures of all the states, that are A, B, C and D. And you can clearly see that D is the final state of our epsilon NFA. Now, in these 4 sets, let's check where is D. So D is present in the epsilon closure of A, D is also present in the epsilon closure of B, and D is also present in the epsilon closure of D. That means the final state of epsilon NFA, which is D, is present in the epsilon closure of A, B and D. And that is why the final states of the resulting NFA will be A, B and D. A, B and D. This is how we calculate the final states of our resulting NFA. Now let's move to the step number 4. Step number 4 is to construct the NFA transition table and the transition diagram. So we have calculated all the new transitions for our resulting NFA. And now we need to construct the NFA transition table and the NFA transition diagram. So this is the basic structure of the NFA transition table. A, B, C and D are the 4 states of our NFA. As you can see, we have the 4 states A, B, C and D. And 0 and 1 are the 2 input symbols. And we have just calculated that A, B and D are the final states of our resulting NFA. Now we simply need to fill these blank cells according to these transitions. A on 0 gives A, B, C and D. So A on 0 gives A, B, C and D. In NFA, multiple next states are allowed. A on 1 gives D. So here A on 1 gives D. B on 0 gives C and D. B on 1 gives D. C on 0 gives phi, or we can also leave this cell empty. C on 1 gives B, D. D on 0 gives D, and D on 1 also gives D. So this is the transition table of our required NFA. As we have got the transition table of our NFA, it is a very simple task to convert the transition table into the transition diagram. We have the 4 states A, B, C and D. A is the initial state as well as the final state. B and D are the other final states, and C is just a regular state of our NFA. Now we need to complete the transitions as per this table. A on 0 gives A, B, C and D. So A on 0 gives A, B, C and D. A on 1 gives D. So A on 1 gives D. B on 0 gives C and D. B on 0 gives C and D. B on 1 gives only D. So B on 1 only gives D. C on 0 gives nothing. C on 1 gives B and D. C on 1 gives B and D. D on 0 gives D and D on 1 gives D. That means we will create a self loop of 0, 1 over the state D. This is the transition diagram of our NFA that we have constructed from this transition table. And in this way, we have completed our conversion process. In the first step, we have calculated the epsilon closures of all the states of epsilon NFA. In the second step, we have created the new transitions for our resulting NFA. In the third step, we have calculated the final states of our resulting NFA. And in the fourth step, we have constructed the NFA transition table and NFA transition diagram. Now, it is your responsibility to convert the following NFA into its equivalent DFA. So we have the transition table as well as the transition diagram of the NFA. And now you need to convert this transition diagram of NFA into the transition diagram of DFA. We have already understood this topic, that is the subset construction algorithm. So as a part of your homework, you need to convert this into a deterministic finite automata. In this way, we have completed our topic Epsilon NFA to NFA conversion. In the next lecture, we will solve one problem based on Epsilon NFA to NFA conversion. So this was all from my side for this lecture. Thank you, and I'll see you in the next lecture.